Ever wonder how your favorite apps handle all that data behind the scenes? It's likely powered by a robust REST API. In this video, I'll show you step by step how to build your own efficient and scalable REST API using Node.js, Express, and MongoDB, transforming complex data management into a seamless experience. And if at any point the code feels a bit overwhelming, feel free to check out complete guides for Node.js and JavaScript that I linked in the description below. They're great not only if you're just getting started, but also if you're an experienced developer looking to refresh your skills or fill in a few knowledge gaps.
I am in an empty folder in the Visual Studio Code. Let's go ahead and quickly create our application. We will start with npm init-y. We got package.json initialized. Let's go ahead and install the dependencies. Since we're going to be working in TypeScript, we're going to be installing TypeScript, types node, and a tsconfig node22. This is the base for tsconfig that we're going to be using, and we're going to be extending the node24 config base. Currently, Node is in long-term support, version 24. If you have a different version of Node, when you're watching this video, you're obviously going to change it to the version of Node that is current for you. And we're going to be installing this as a dev dependencies. Let's go ahead and create tsconfig.json file in the root of our folder. And in this file, we're going to put the following code. As I mentioned before, we are going to be extending tsconfig node24 and tsconfig.json file, and we will be putting all our TypeScript files in the src folder. In the compiler options, we will specify our output directory as the dist, and root directory will be the src. We will also specify force consistent casing in file name as true, and we will set source map as true as well. We will need source map to troubleshoot our application. We are compiling our TypeScript into JavaScript files, and when the error is thrown, the error stack will give us the JavaScript file. However, we are coding in a TypeScript file, so source map will let us map the JavaScript file into corresponding TypeScript file, and that way our debugging will be much easier. However, source map configuration option won't work by itself. We will need to install another library, and this library is called source map support. So let's go ahead and install it with npm. Great, we're all set with the TypeScript. Let's go ahead and install Express and other libraries. We will do npm install Express, Course, and Morgan. We will also install the types for Express, Course, and Morgan as a dev dependencies. Great, now let's create src folder and scaffold our application. So in the src folder, we will create server.ts file. So in the server.ts file, we're going to put the following code. First, we are going to import source map support register from the package we installed earlier. This will help us to map JavaScript files into TypeScript files. We will be importing also Express from Express, Course from Course, and Morgan from Morgan. First, we are going to create an app, right, by calling Express. Then we're going to put app use course, and course is the middleware. This middleware will allow us to accept the requests from the web browsers that are made with a fetch request, right, or AJAX request. By default, browsers will only allow to make AJAX or fetch calls to the domains that the application is served from, but the course package will tell the browser, or basically is going to create the headers that will tell the browser to say it's okay, you can send the request to a different domain, the domain where our API is served from. The next middleware is Morgan middleware, and this middleware allows us to log requests that come into the application, and there are different formats there. I usually use tiny format. If you want to learn more about middleware, you can just go ahead and look at the documentation. Finally, the third middleware that we are going to be using is Express JSON middleware, and this middleware will let us parse the body of the incoming request. We're going to be using JSON body in our requests, so Express.json middleware will parse the body of those requests. Finally, we will export default our Express app. Now in the src folder, let's go ahead and create index.ts file. In this file, we will use the code to run our application. We're going to import our Express application from a server.ts file. We'll then specify the port by using parse integer, and we'll get the port from the process env. And if the port is not specified, we will put the default port of 3000. And then we're going to call the listen method on the app. We will pass the port, and we also put the console log. Express is running on the port, and we're going to use the port that we specified. And since we're taking this port from the environment variables, I will show you how to load these environment variables from the .env file. Now let's go to package.json file, and we will create the commands that will allow us to build, start, and run our application in dev mode. So build command will use the TSC. The start command will basically run the index.js file that was built in the dist folder. And the dev command will actually let us automatically restart files when the files are changed and load env variables from the .env file. So here the tswatch command will basically look for files, TS files that are changed, and on success, it will run the command node dist index.js to run the index.js compiled file. And then .env command will basically let us load the variables from the .env file. However, this command won't work by itself, as you already guessed. We will need to install a couple of libraries. Those libraries are tscwatch and .env CLI. Let's go ahead and install them as the dev dependencies. Now let's go ahead and create a .env file in the root of our folder, and we can put a couple of environment variables here, and specifically node.env. It will be development, and the port that we're going to be using, in our case, we'll just put it as 3000. In production, you will specify environment variables depending on where you are deploying the application. There will be specific instructions. However, in development, they will be picked up from the .env file using the package .env CLI right here and command .env. Great, we're all set. Let's try running the application with the command npm run dev. And we got the message, Express is running on port 3000. This is great, our application is running. However, it doesn't do anything, right? Because we don't have any route handlers. Let's go ahead and create them. We will create routes to handle tasks CRUD, or namely create, read, update, and delete tasks. So let's go ahead and create in the src of our folder, the folder name routes. You can name this folder however you want, but there is a convention to name this folder routes because we're going to be placing our routes in this folder. So let's go ahead and create tasks.cs file in the routes folder. And in this tasks.cs file, we're going to put router, which will be an express router that we will use for the tasks. We will create the tasks router by calling a router method with a capital R on the express that we're going to import. The next thing that we're going to do, we're going to create the get route. This route will be responding with a JSON, and it will give us the list of tasks, right? Currently, we are hard coding the tasks, but later on, we will be getting them from Mongo database. The next route is get task by ID. We have a route parameter ID that we get it from the request, and then we'll respond with JSON, faking this task ID as if we're sending this task back to the user. The next route will be to create a task, right? We just get a title from the request body.title and then complete it from the request body.completed. And as you remember, we installed Express.json middleware. It will help us to parse the body of the request right into an object where we can grab title and complete it. And then we're going to respond back with JSON with the same properties, faking that we created the task. Next, we're going to have a put route. This route will update the task, and the request params.id will tell us which task we're updating by ID. And again, we'll just fake respond with a JSON that we updated the task. Finally, we're going to use the delete operation or delete route to basically delete task. Again, the ID will be specified in our route parameters, and we will respond with a success message that the task with the specified ID was deleted. Now let's go ahead and add the task router to the server.ts file. So we are going to import the task router from routes tasks.cs file. And then below the middlewares, we will put app_use/tasks. This will be our request prefix, and we put the task router. And it is important to put this task router below the middlewares, specifically below the middleware express.json that will allow us to parse the JSON body of the requests. Finally, let's go ahead and create an error handling middleware. So in the src folder, let's create another folder called middleware. And in this middleware folder, let's create a file called errorhandler.ts. And we're going to put the following error handling middleware in this file. Error handler middleware helps me uniformly handle errors that are thrown by the application. This can be an unexpected errors, right, that I don't know even exist. They're gonna fall through and get caught here and appropriately handled and sent back to the user, or it can be an expected error that I can pass in here, and I will use the same code, right, to get the error message and send it back to the user, and it will make my code dry so I don't have to repeat the same code in my routes. As in the regular middleware, we're going to be using request, response, and next. So we're going to import these types, request, response, and next function from Express. We will also import a function getErrorMessage from the utils.cs file. This function doesn't exist yet. We're going to be creating it in a minute. The error handler middleware behaves exactly the same way as a regular middleware, so we will be exporting default function error handler. However, the first parameter that we're going to be passing is actually an error, and this error will be type unknown, because in JavaScript or TypeScript you can throw anything. Then we'll put our request, response, and next. First, we're going to check res.headers_send. This means our response has been already sent, and we cannot really send another response. In this case, we will use the next function and pass the error to Express's built-in error handler. Built-in error handler does a very good job in actually logging the error, so I prefer to use that. And then we simply return. If the response has not been sent, we will send our own response, and we'll use the status 500 here, and 500 means that something wrong happened on the server. There are two basic types of the response, 400 and 500. 400 usually means that the server kind of understands the response and the error lies within the client who is making the request. 500 usually means that something happened on the server and actually the server fault. So in the most cases, this is going to be the errors that happened on the server. So we will send the status 500, and then we will send the JSON response with the property error and the message. And here, since the error is unknown, we cannot just get error.message, right? We will have to use utility function getErrorMessage to get error properly. So let's go ahead and create this file. So in the src folder, let's go and create a new file called utils.ts. And in this file, we are going to put the following code. From the utils files, we're going to export function getErrorMessage, and we'll pass it error as a parameter of type unknown, and this function will be returning the string, right? We will have a few conditionals where we check if error is an instance of error, then we can access message property on the error and return it. If error is a type of object and it has a property message, then we can access this message and cast it to string and then return it. If the error is itself string, then we can return this error. And finally, if none of these conditions match, we will return a default string and error occurred. Now, if we go back to error handler, you can see that the TypeScript stopped complaining and we're all good here. So we can use this error handler in our server.ts file. In the server.ts file, first we are going to import error handler from middleware error handler, and then we're gonna use method use, no pun intended, on the app and pass it the error handler. And it is important that your error handler middleware is the last thing that you call before you export your app, because in this case, all your errors will actually get caught in this error handler. Now we have routes that we can actually call, and those are tasks routes. Let's go ahead and test our application. And the way we're going to be doing it is with a plugin that is called REST Client, right? This is the plugin for the Visual Studio Code that you can install if you don't have it installed. I already have it installed, so all I have to do is to create a file with .http extension. So in the root of our project, let's go ahead and create that file. We call it API test.http. So in this API-test.http file, we'll put the following code. Basically, this is the code to make requests to our API. This file is going to work similar to the Postman, right? If you know the Postman application to test APIs, so this file will be basically the same as Postman. The first call will be to the tasks route, and it's going to be the get request, and we're going to put 3 hashtags here, and we can say that's a list task request, right? It is important to put these 3 hashtags so you have this send request option. The next one will be get task by ID. Then after that, we have a create a new task, right? And this will be a post request, and it is important to put content type application JSON header. So we telling our application that we're sending a JSON body of the request. So, and that's how the middleware express that JSON will kick in and understand that, hey, I gotta parse this JSON body into an object. Additionally, you can specify other headers. In our case, I put X API key, right? It's going to be an API key, my secret, but for our purposes, we don't really need it, so we can delete it. The next call will be to update a task. That will be a put call. Again, we're sending the body, so we will have to specify content type application JSON header. And finally, there will be a call to delete a task, right? So we'll use delete method, and we send it to the tasks, and we'll specify what task ID we want to delete. Great. Now let's go ahead and spin up our application with npm run dev and do a test. Got a message that Express is running on port 3000. Let's go ahead and make a call to list our tasks. And as you can see, we got this request logged because of the Morgan middleware. It goes to the tasks. We got the response 200 back, and we got the list of tasks. Obviously, we're faking it for now. The next thing that we're going to do is to try to get the task by ID, and we received one task in the response. The same goes for creating the task, updating the task, and deleting the task. So our API is working. So the final thing that we actually need to do is to set up the GitHub repository, right? So let's go ahead and create the .gitignore file in the root of our project. In this file, we're going to be specifying which files we're not going to be committing and pushing to the repository. So those files are going to be the files in the node modules. Next, it will be the dist folder, because we're just compiling our files and we don't need to push it to the repository or commit them because they're going to get recompiled. And finally, the .env file, because we're going to be saving our environment variables and sensitive information, and we don't want to push that file to the repository. However, if you're working with other developers on a project and would like to let them know what environment variables your project is using, you can actually create a .env.example file in the root of your project, and where you can paste the names of your environment variables without the values. That way you're going to keep your sensitive information sensitive and secure. Now let's go ahead and initialize the Git repository in our project. So we'll do it with the command git init. And the Git repository is initialized. And as you can see, the dist, the node modules, and the .env files are grayed out, so they're excluded. And we need to make a commit, right? It's going to be an initial commit. So we're going to do git add space dot command. It will add all the files. And the next command that we're going to do is commit, right? So we'll put git commit, and then we can put the message with a -m, and we'll put initial commit. And now our files got committed, and we can set up Git repository and push our files to that repository. Great, we're all set. Now we can set up MongoDB database. But before we do that, if you're enjoying this video, please hit the like button and subscribe to our channel for more videos like this. So the easiest way to run your MongoDB locally is to actually use Docker. So let's go ahead and create a Docker compose.yaml file in the root of our project. All right, and we're going to paste the following code in here. In the docker compose.yaml file, we will specify the version, right? Currently, I think it's 3.8, maybe different at the time when you're watching the video. Next, we're going to put the services, right? And there will be one service called MongoDB. We're going to use image Mongo 7.0. We'll just call the container REST API Mongo dev. Restart will be unless stopped. The ports will be 27017, and we're going to map that 27017 port on our local development machine to the 27017 of the port the Mongo runs inside the container. 27017 is the Mongo default port, so we can just use it as is. In the environment, we will specify Mongo init db root username, which will be admin, Mongo init root password will be password, and Mongo init db database will be the task manager database. Finally, we'll connect the volumes, right? MongoDB data and MongoDB config. And then we'll create a network. It's called REST API network. And then we're going to have the volumes that we specified earlier right here and the network with a driver bridge. And this is a very simple Docker Compose file to be able to run MongoDB locally. Obviously, to do that, you should have your Docker installed on your local machine. The easiest way to do it now is just to install the Docker desktop. They're available for both Mac OS and Windows, so just go ahead and install it if you don't have it installed, and then you can use Docker on your local development machine. In order to spin up the database, we will use the command docker compose up, and we'll put -d flag. It's going to be running in a detached mode. So if you don't have Docker container, specifically the Mongo one, right, it will take a little time. In my case, I already have the container pooled, so my MongoDB got spun up and is ready to use very fast. So now, since we have volumes, right, we can start writing the data to our database and not be afraid, right, if we spin down our database, and you can do it with the command docker compose down, and our data will still be preserved because we're using the volumes. Okay, let's go ahead and spin up the database again with the command docker compose up-d. And now let's go ahead and establish connection to this database. So the first thing that we need to do is to specify the MongoDB URI in our environment, and we'll put it in the .env file. So MongoDB URI variable will have MongoDB string, right? The protocol will be MongoDB. Then we're going to have a username, admin, and password as password. Our MongoDB is running on localhost port 27017, and the database we're going to be using is a task manager, and then auth source will be admin. Next, let's go ahead and create a connection file in the source folder or SRC folder of our project, and the file name will be db.ts. So let's go ahead and put the following code in there, and we're going to be importing first Mongoose from Mongoose. There are different ways of interacting with a MongoDB, and one of the way is to use object document mapper, which is Mongoose. Mongoose is basically a counterpart of object relational mapper. If you're working with a relational database like Postgres or MySQL, you can use ORM such as SQLize or Prisma. But if you work with a non-relational or non-SQL database like Mongo, the object relational mapper becomes object document mapper, and the most popular is Mongoose. So we will be using Mongoose to interact with our Mongo database. And if you want to learn about Mongoose, there is the documentation right here, mongoose.js.com. You can read the docs, and it will explain you about the schema, about the documents, queries, and how to use the Mongoose API to query your models. Let's go ahead and switch to Visual Studio Code, and we can install the Mongoose library so we can work with a Mongoose ODM. Mongoose is installed, so TypeScript doesn't give us any errors anymore. So we're gonna have a constant MongoDB URI, right? We'll get this constant from the env variable MongoDB URI that we specified earlier, and then we're gonna export async function connect to database, right? And here we're gonna have a try-catch statement. We're gonna call await Mongoose connect, and we'll pass it MongoDB URI, and then if connection is successful, we'll console log connect to MongoDB successfully. However, if it's not successful, we'll have a catch statement with an error right here, and here we're gonna have a console log error, or rather console error, failed to connect to MongoDB, and we'll have process exit 1. And then we're going to be exporting default Mongoose right here. So now we can use Mongoose to create models and query those models. However, before we do that, we'll need to bootstrap this connection to our application. So let's go to index.cs file, and first we're going to import the connect to database from db.ts file. The next thing that we're going to be doing, we can remove this app listen right here and have the async function start server. This will be basically a wrapper around connect to database, right, method, because it's an async function, so we'll need to call await, right? And if it is successful, we will again call the listen method on the app, and console log express is running on port. However, if there is an error, we console error it, failed to start server, and exit the process with 1. So now all we have to do is to basically call the start server function. Now let's go ahead and test this connection. We can do it with, again, npm run dev. And now we got 2 messages connected to MongoDB successfully, and Express is running on a port 3000. So our application is connected to MongoDB and is ready to go. Now we can create models and query those models. And I think I forgot to mention, the code for this video will be available in the GitHub repository, so please check the link down below in the description. We got the connection working, so let's go ahead and create a model so we can interact with it, put data in the database, and query that data using the model. In the src folder, let's go ahead and create another folder called models. In this folder, we're going to be creating a file called task.cs, and this will be our model, so it's capital T. Next, we are going to import Mongoose document and schema types from Mongoose, and we will create an iTask interface. It will extend the document, and in our task, we're going to have properties name, optional description, due date, completed, and created at and updated at. Next, we are going to create a task schema. So here we instantiate the new schema from Mongoose and pass it iTask interface. NoSQL databases in general are schemaless, but still need a schema to give your data some structure and get the validations. NoSQL databases are schemaless also in terms of that we don't need to do any migrations here. We just define our schema in the code, and unlike with relational database, we won't need to do any migrations to create this structure in the database. So the first property we have is name, and then the task schema or schema in general allows us to define the type of this property. We can do validation, so we put it's required. We can actually trim, if users put spaces before or after, right? Input has it, so we can actually trim it. And then also we can put a max length, so to prevent too long of the name. The same goes for the description, right? We have a again type of string. Now description is not required, unlike name. We also can trim the description, and we put the limit, the maximum length of 500 characters. The due date is also optional, and it's going to be a type of date. And then we have a completed, will be a type of boolean, and we can even set the default value as well, so it will be false. And finally, we can put the timestamps right here. We'll set timestamps true, and this will account for created at and updated at dates. Next, we're going to create our task model, which is going to call model method on Mongoose. We'll pass it iTask interface as a generic, and then we call our model task, and we'll pass it the task schema. And finally, we're going to export default task, and then export the type iTask as well. We're all set. Let's use the task model in our routes. So in the routes folder, tasks.ts file, first thing we're going to be doing is importing our task from models task. Next, let's update the get tasks request handler here. So we're going to put the following task router get. So basically, we're going to be looking for tasks and sorting them by created at descending. And then we're going to return those tasks as a JSON. And for some reason, if we encounter an error, we have a catch statement, and we'll use the next function that we also passed as our parameter to the route handler to pass it to the error handler. And our error handler will extract the message and return it to the user. The next route is get task by ID. Let's update it as well. We will use the task model to find the task by ID that we get from the request parameters. And if there is no task, we will return a 404 response saying that the task is not found. If there is a task, we will return it as a JSON to the user. And also if there's any errors, we will pass it to the error handler. So the next is the post route to create a task. Let's go ahead and update that. So first, we're going to destruct name, description, due date, and completed from the request body. Then we create a new task model, right, and pass it the name, description, due date, and completed at. And then we can put the data in a database or create the task in a database by calling method save on this task. And then after everything is successful, we will return the status 201, and 201 means created, and also the JSON representation of the task. If something goes wrong, again, we will pass the error to the error handler. The next route is a put route to update the task. Let's go ahead and update that route. So we're going to put the following code in here. We're going to, again, distract name, description, due date, and complete it. Next, we can use a very helpful method, find by ID and update on our task model. The first argument to the method is going to be task ID that we're going to get from the request. Then we put the values that we distracted from the request body. And finally, we'll put another object where we specify that new is true and run validators is true as well. So run validators true is kind of self-explanatory, right? We're going to run the validators that we created on the model. The new true means that the task that we're going to get here, that this method find by ID and update will return to us, is the task that will be updated. So that's going to be a new task after the updates. So that's why we need to put new true. If you want to actually get the original task before the updates, then you don't put new true, you just put new false. Next, we're going to check if we get a task back, right? If we don't get the task back, we will reply with a status 404, task not found, because the ID of the task may not be correct. And if we get the task, updated task, we will return it as a JSON back to the user. And then again, we will handle our error by catching it and passing it to the error handler. And finally, let's go ahead and update the delete route. So we are going to be using the delete method with a parameter ID. We're going to grab it from the request parameters, and we'll use the method find by ID and delete. And this method will return a task to us as well. If there is no task, we will return that the task is not found. However, if we get the task, that means the task was deleted, we will return the JSON response to the user with a message task deleted successfully. And as usual, if there is any error, we will pass it to the error handler. So we're done updating our task routes. So our CRUD is completely updated with a task model, so we can communicate to the database and put the data in the database. And now let's go ahead and test it. Just be sure you have your Docker running with your Mongo database, and then you just need to run npm run dev. And we got the message that we connected to MongoDB successfully, and Express is running on port 3000. Now let's go to api.test.http file, and we're going to make a GET request to get the tasks. And we got successful response with a 200. However, we don't have any tasks, right? Because we haven't created any. So let's go ahead and create a task right here in the create task call. We can just update the body that we were going to be sending. So let's go ahead, let's send the request. And it looks like that our task was created successfully. So we got the response back, and besides the properties that we already defined and sent to be created, and we also have created at and updated at timestamps, and we also have an underscore ID and also underscore V. So underscore ID is obviously the ID of the task, and underscore V is the internal version of the document. Let's go ahead and try updating this task. So first we're gonna put the new payload, and then we will need to copy the task's ID, so we can send the request and update specifically this task. Let's go ahead and send the request, and as you can see, the task got updated. So we have the new description for this task. Since we copied the ID, let's go ahead and try to get this task by ID, right? So let's put the ID of the task right here and send the GET request. And the GET request by ID worked as well. Nothing really changed because, the task is the same. Finally, let's go ahead and try to delete the task. So we're going to put the task ID in here and send the delete request. And we got the message that the task deleted successfully. So now if we try to get a task by ID, we will get a message that the task is not found because there are no tasks in the database. Mongoose ODM has a lot of powerful feature, and in this video, we're going to look at the feature of querying our tasks. But for other features, I encourage you to check Mongoose documentation. So let's go ahead and add an ability for the user to filter our tasks. So in the routes tasks.ts file, let's go ahead and scroll all the way up to the get method, and let's update it. So first, we're going to be creating the filters, right? We're going to distract name, due date, from and due date to. Those will be our filters, right? We will be able to filter task by name and specify the range, right? From and to, maybe tasks between certain dates or tasks after the date or before the certain dates. So we'll define filters, right? For now, we'll just put an empty object here. So if we have the name, right, we'll just applying a regex expression. So the name and the option will be I, which means the case insensitive. So basically we will be looking for a regular expression that kind of contains the name, sort of a fuzzy search. Next, we're going to check if due date from or due date to exists on a query. So if they do, we'll add a property due date to our filters. It will be an empty object for now. And we check if there is a due date from. So then the due date will get another property that is $GT or greater, and it will be a new date, and where we cast due date from as a string. And then if we have a due date to, again, we add the property $LT or less than, and then it's going to be another new date, due date to, and we'll cast it as a string. So basically, if we have due date from and due date to, we put the boundaries on the task due date, right? So we can filter specific tasks that fall into the range. Next, what we need to do is to pass this filter into the find method. And we're all set. So now we will be able to filter our tasks by name and the due date. Now let's go to the API test.htp file and create a couple of tasks. Right, we're going to create one task, and then let's go ahead and paste another payload and create another task. Now if we use the list tasks request, right, we can get the array with the two tasks. But however, we can also now use the filter queries, right? So we can get a request that can filter tasks by name, for example, filter task by due date, and filter task by name and due date. So let's try those requests, right? We're going to send the request. We're going to get one task that is filtered. Let's try filter task by due date range, right? Click again. We still got a response where that contains two of the tasks. And finally, filter task by name and due date. Right, so if we click on there, we get a response with one task. So our filters are working, and that's how easily you can use your MongoDB and Mongoose ODM or Object Document Mapper in particular to query the data, to create the data, and to actually filter data with the different properties. Another great feature of MongoDB is that it easily allows for testing. It has a package, MongoDB memory server, that we can use where we can put our database, Mongo database, in memory and run all the queries that we want to test if the data is recording in the database correctly. So all these requests that we are doing in API test.htp file, we can actually automate. So let's go ahead and do just that. In order to do that, we're going to install several packages. It's going to be MongoDB memory server that I mentioned. The next will be Jest. Jest is our basically a test runner, right? It will allow us to run the tests. The Jest library will allow us to run Jest within TypeScript. Then we're going to install the types Jest and also the Supertest. And the Supertest library will allow us to actually make the requests, right, the same way this API client does the API test.htp file. And all these dependencies need to be installed as a dev dependency. So let's add the flag -d. After the packages are installed, let's go ahead and create the Jest configuration file. In the root of our folder, let's create the file called jest.config.mjs, and we're going to put the following code in there. So we're going to export default. The preset will be tsjest, so we can run Jest in the TypeScript. The test environment will be Node. The roots will be src tests. That's where we're going to put our tests. We'll also have a transform, right, that we'll use with a tsjest to be able to run the TypeScript files. And then we'll have a test regex, so we'll have a regular expression to look for the tests in also __test__ directory, because it's usually a common directory where we put where the tests are put. Also, we're gonna look at the files that have test or spec extension, and then says .ts, maybe ts, right? It's optional. And then we'll have module file extension of ts, js, json, and node. Next, let's go to the package.json file, and here in the scripts, we're going to add another script. This script will allow us to run the tests. It's going to be called test, and we're going to be running Jest. Next, we also gonna update tsconfig.json file. In the compiler options, we'll add another option, and this is gonna be isolated modules true. So this option is for the Jest actually to run, with a TS node. So for some reason it complains and asks you to put isolated modules to true. The next option that we're gonna add will be an exclude option, and we just add it to the root of our config.json file. It's similar to include, but obviously it excludes files. So we're gonna say that we're gonna be excluding src tests files, all the files in the src test folder, or any other files that have .test.cs extension. The reason we're excluding these files from the compilation is because we're running TS node, and TS node will run our tests on the fly. So basically we don't need these tests in our dist directory, right, when we deploy our application, for example, because tests just add overhead. Next, let's create a tests folder in src directory of our project. In the tests folder, we're going to create a file called MongoDB Setup.cs. This is the file where we're going to be setting up the Mongo database, or MongoDB memory server in particularly. So we're going to import Mongoose from Mongoose, and then Mongo memory server from Mongo memory server. We will declare Mongo server as a type of Mongo memory server. Next, we're going to call two functions, before all and after all. In the before all, we're going to pass it an async function that will create a Mongo server, and we're going to be using Mongo URI that our Mongo server will provide to us. And then we'll do the connect command so we can connect to the Mongo memory server. And then after all function, it will basically disconnect Mongoose from Mongo server, and then it will stop the Mongo server. So as you may have figured out, these before all and after all functions will be running before the tests and after the tests. Now let's create the tests themselves. So in the tests folder, let's create another file called tasks.test.ts. And in this file, we're going to put a few tests. So it looks like we got a few TypeScript errors here, and the reason for that is because we're actually missing one more library. It is called types Supertest, right? Because these methods that we have and that are highlighted are called on the Supertest. So let's go ahead and install the types for the Supertest with npm install add types, and we'll put Supertest, and we'll put a D flag to install it as a dev dependency. All right, the library is installed and the error went away. So let's go ahead and scroll all the way to the top of the file and go over a few tests. I put a lot of tests here, but I'm not going to go over every test. You can see the code for this test in the GitHub repository that I linked in the description below. So first we're going to import request from the Supertest. Then we're going to be importing Mongoose from Mongoose and Mongo Setup that we just created. And then we're going to import the app from our server, and then import the task from the models task. And then before each test, we're going to run the function or method to delete the tasks, right? So our database is always clean. Next, we're going to describe our tests, right? It's going to be the test CRUDs, and then in particularly, we're going to have tests for the getTasks method, right? And the first test will say it should return an empty array when no tasks exist, right? We're going to make a request using the Supertest and pass it the app, and then we're going to have a method getTasks, right? And the response from this call should be empty. So we're going to check that the status of the response is 200, and then the body, the tasks that are returned, will be an empty array. Next test will be it should return all tasks, right? We're going to create one task, create the second task, and then we're going to again make a request to get the tasks. We will check if the response status is 200, and then the body of task, we're going to have a length of 2 because we just created 2 tasks and we're getting 2 tasks out. We're going to make sure that ID of the task is defined, the name of the first task is defined, name of the second task is also defined. And the reason that we get task 2 before the task 1 is that the tasks are sorted by created at descending, means the newest tasks will be returned first. And then in the tasks.cs file, in the get method, we have created at -1, meaning that the newest tasks will be first in the array. Next, we have the test to be sure we're filtering tasks by name, case insensitive. Again, we're going to be creating 2 tasks. Then we're going to make a request, and now we're going to have a query string. The name is project, right? And then we assert that the status again returned is 200, and we only have one task, right? Because the filter got one task out of 2, and we're going to check that the name is complete project setup. So you can take a look at other tests. They kind of have the similar pattern, right? We basically make a request with a Supertest, and then we assert the status and the body of the returned result. Now let's go ahead and try to run the tests, and we can do it with npm run test. And as you can see that the tests ran super fast because our database is in memory and all our tests are passing. And the final point that I want to address is actually the usage of this task model, right, where we call task find by ID, right, in our routes. And the problem with that is that this is not a very good pattern because you have like bad separation of concerns. The testing can be a little bit harder when you need to reuse, right? There is really no reusability. When you create new routes, you'll have to kind of use that model. It's going to be hard to maintain as well because, you know, as project grows, you know, you have your model in all those different places. And let's go ahead and fix it, right? The normal thing that you can do is basically create some kind of service, or I prefer to create a repository, right? We can just go ahead and create a simple task repository that we can be using in these routes. So in the src folder, let's go ahead and create another folder called repositories. And in this folder, we're going to create a new file called task repository. And since this is going to be a class, we have the capital T right here. So in the task repository, let's go ahead and put the following code and take a look at it. First, we're going to import task and iTask from our models. We're going to have an interface for the filters. I'm going to call it task filters. Right, I'm going to have a name, due date from, and due date to. Then we're going to create a class, task repository, and this task repository will have some methods, right? We're going to have get all tasks method. We're going to pass it the filters. It will be of type task filters, and this method will be returning the promise, right, with an array of type tasks or iTask. Then we're going to again have the same logic that we have in the routes to check for the filters, and then call the find method on the task and pass it a filter, and obviously we'll still keep the sorting where we return the newest tasks first. So the next method will be get task by ID, right? We're going to pass the ID and call method find by ID on the task. Creating task is also fairly simple. We'll just create the new task with the task data that is passed in that method, and then we'll just call tasks save method and return that task. And then method update task, right? We'll pass the ID and the task data. Again, we will use the find by ID and update method on the task, the same method that we used in the routes. And then again, property new will be true, and we'll run also validators. And finally, delete task method will require an ID that is a string, and then we'll use the method find by ID and delete on a task and pass that ID. Basically, as you can see, this repository is simply a wrapper around our task model. And this wrapper and the concept is fairly simple, but it will allow us for separation of concerns, easier testing, reusability, and maintainability. After the task repository is created, we will instantiate it and export it as a default. And this task repository is fairly simple, but if you know my videos, I kind of prefer an approach of a more complex repository that uses TypeScript mixins. And if you like to learn how to do it, please check out the video on mastering repository pattern with a TypeScript. Okay, repository is done. Let's go ahead and update the tasks routes to use this repository. Let's scroll up a little bit and see how it looks now. So we are importing task repository from repositories task repository. And again, we still have the task router. Everything is the same. However, in the methods right now, we get the filters property that we'll need to pass to the task repository, get all tasks. And then we get the response back and we return it as a JSON as we did before. In the get task by ID, we have again task repository that we call the method get task by ID on, and then return the results. In the create tasks route, we call the create task method on the task repository, where we're passing name, description, due date, and completed at the properties that we distracted from the body. The same goes for the updating the task. we use the update task method on the task repository, and finally deleting the task, we just call the delete task method and on the task repository and pass it the ID in the request parameters. The refactoring to repository is completed, and we actually don't need to go to API test.http file anymore to test our work because we have a suite of our tests, right? The tasks test that we can run to make sure we didn't make any mistakes when we refactored the code. So let's run npm run test. And we can see that all the tests are passing. That means our refactoring is successful and we didn't really make any mistakes. And that's all there is to building a scalable REST API with Node.js and MongoDB. If you want to take your skills further, check out my course, Node.js REST API Mastery, Build Powerful APIs with Express, where I build a complete production-ready API step by step.